All right. Hello and welcome everyone to the quick webinar, All Things Quick with Stefan Eissing and Daniel Stenberg. My name is Marcos. I'll be moderating the webinar. All attendees will be in listen-only mode. If you have questions, submit them using the Q&A box. We'll be hosting a Q&A session following the presentation. I invite you to follow us on Twitter at wolf4thecell as well as our other socials. Also, feel free to email us at facts@wolf4thecell if you have any questions regarding curl or wolf4thecell. But that's all for me, so I'm going to hand off to Daniel now to get the presentation started. Thank you.
Hello and welcome to this presentation. It says All Things Quick right in the description. I have another description or title here on my slide here. But okay, this is Quick and HTTP3 with curl and wolf4thecell, right? So I wanted to, and I'm going to do this in a way to describe a little bit about HTTP3 and Quick and how wolf4thecell supports it, how we can build curl or build curl to use HTTP3 and doing transfers with curl, right? And also a little bit about how to do it with libcurl. And I want to just mention then that we're doing this together. It's me and Stefan. So Stefan is here right beside me and is going to do a little bit a part of this presentation. I'm going to start blabbing a little bit and then I'll let Stefan join in and do his part in a few minutes. And of course, if there's any question or anything, just join in, tap this little Q&A thing in Zoom and ask the question. Or if you're in Twitch, ask your questions in the chat and we will try to get to them in the end. I guess both me and Stefan are here. We can answer most questions around the protocols and curl and everything related, right? So when this Quick protocol, right, that we're talking about here, it's a replace, or rather, it's a new protocol, right? So it's meant to fix a lot of problems or introduce a new era in transport protocols. And when the team, the group in the IETF decided to let's do a new transport protocol, they took they decided to go ahead and work and fix and polish a lot of different things when it comes to transport protocols. So for example, the Quick addresses the TCP head of line blocking problem. It makes faster handshakes down to 0 RTT handshakes. It can send data earlier in the handshake and fixes the old problem that we call with TFO, right? The TCP fast open problem. And it features more encryption always. So it's where TCP and TLS still has a few things that are in the clear. Quick has gone one step further and is even more encrypted. And hopefully then, by doing more things encrypted, we can do things better and potentially, hopefully, ideally, actually be able to fix and change things in the future as well. Sort of overcome a little bit of this ossification that we see otherwise in the protocol world. So Quick is a new transport protocol, right? But it is built on top of UDP. So it's UDP and TCP, they remain the only protocol ones that we will see and use in that OSI layer, right? Or above the IP. They will remain the ones. So Quick is instead a new layer on top of UDP, sort of TCP implemented on top of UDP, a replacement for TCP and TLS. And it's a reliable transport protocol implemented in user space. And with Quick, we get streams, the same way that we got streams previously in HTTP2, but now we get it in the transport protocol. It has been done before, but now we get streams in the transport protocol that we didn't have with TCP. So that means that we have many logical flows within a single connection, right? So we can set up, and they are independent, so they can work. If one stream has a problem, the other streams can continue, and so on. And previously we had that in HTTP2, but not in the transport layer. And yes, the streams are independent. If we drop packets that are related or belong to one stream, the other streams can still go on and continue uninterrupted. So just a reminder then, so that this is the old style HTTP stack. We've seen it before, you know it. It's built on an IP, right? We put TCP on that, and the connections are in TCP. That's the kernel space. And we add TLS on top of that, and we speak HTTP 1. This is how we've done it for, well, TCP and HTTP 1 started to get specified in 1997, so it's been a while. So on top of that, of course, we have the the HTTP semantics, and they are really what will remain here between all the different versions. The semantics are the same, but we change things underneath. So from HTTP 1, we went to HTTP 2, and then we sort of switched out the HTTP 1 part, and we added HTTP 2. So we got a new way to do. We added streams. You could do header compression. We had the server push. So we changed how the HTTP was done over the wire, right? But the semantics are still the same. It was still the same TLS and TCP underneath. Introducing HTTP 3 and QUIC, then it looks like this. We rebuild the entire stack on top of UDP instead of TCP. We add QUIC on top of that. That's the transport layer, right? It replaces TCP and TLS, and it does the streams. It does the TLS, well, the security part, the encryption, and it handles connections. And then we add HTTP 3 on top of that, featuring header compression and server push again. And of course, on top of that, still then the same HTTP semantics. And by HTTP semantics, I mean the regular headers, the verbs, you know, the regular request response things, the ones you're accustomed to see and work with, and they will remain the same, no matter which protocol version you use, no matter how it actually sends stuff over the wire, right? We changed everything over the wire, everything on top is still the same. That's at least sort of the idea, right? Supporting HTTP 3 and implementing HTTP 3 and deploying HTTP 3 has a bunch of problems. And this is, among other things, is that a lot of connections will simply fail because a lot of organizations and companies block UDP. So there's a strong incentive for everyone who implement HTTP 3 to have fallback mechanisms, so that if the H3 doesn't work, go back to H2 or H1, which of course then doesn't really help, because then the ones who are blocking these connections, they can continue, because most clients will just transparently fall back and use the older versions instead. It's very CPU intensive, especially seen in server side. So if you decide to deploy HTTP 3, you will see that it's 2 to 3 times the CPU performance required for the same bandwidth, mostly due to more crypto and less hardware offload of the crypto, but also very unoptimized UDP stacks in primarily Linux, then, for being the main server platform, but also in the other platforms. So UDP has really been a way to do traffic that hasn't been very optimized over the years. There's also this funny TLS layer, which means that to implement QUIC, you need new primitives for the TLS library, or the access to the TLS functions, basically, because QUIC introduces new ways to do TLS or use TLS that was never used before. So all TLS libraries need adaptions enabled to support QUIC, which then slows down adaption, because not all TLS libraries really are very fast at doing that. And again, then I mentioned briefly, all QUIC stacks are user-land, which is sort of a sometimes a drawback, sometimes a benefit, but there's no standard QUIC API, right? So whatever you want to do as an application, you'll get married to that particular API you go with, and it's not that easy to switch and try out different ones. And of course, then you need new tools, because TCP dump or all the other, analyzers of TCP and everything, they are completely out the window, right? Because QUIC is a new transport protocol. There's no TCP left. There's no TCP to dump. You need new protocols for that. Wireshark is on board, of course, and you can Wireshark it. There are other QVs and other QLog tools to do logging in new ways. but still, there's new things to learn and adapt to. So not just done in an afternoon, maybe. So you need to really get into it. Of course, all browsers already support HTTP3, and they've done it for quite some time. So it's not that new. And when I actually checked this afternoon and checked what the latest Firefox beta, how much HTTP3 does it actually use? It turns out that it's 28% of all responses are HTTP3 in Firefox beta. That happens to be the latest version that I can actually get this data for in a browser. So I think it's fairly good. I don't know exactly how big user population that is, but yeah, it's a number, right? It says at least that it's quite a lot of traffic web browser wise is HTTP3 already. And who's doing HTTP3? We know, first, let's compare HTTP2, of course, at 46%. So yeah, still HTTP1 seems to be pretty prevalent. HTTP2 then, of course, being actually the largest protocol of the 1, 2, 3 family. Looking at the top websites in the world, that this is from the site W3Techs. They do these probes. They check the top 1 million websites in the world and check if they do HTTP2, HTTP3 and stuff. And I found it very interesting that the 25% mark that I'm showing here on the slide is actually pretty much exactly the same as it was a year ago. So it seems that we have reached some kind of, I don't know if it's flatlined, at least the increase, which possibly means that all the big CDNs and big players are here now. So, and it's probably going to slow down when the not so big players are considering this. I don't know. This is just my quick interpretation of this graph, at least. And of course, you can do HTTP3 with curl, and someone who's worked a lot with HTTP3 in curl recently, that's Stefan. So I figured he could say a few words about HTTP3 in curl. I'm going to stop my sharing like this.
Okay. Let's see if I can get this going here. You should see now the first slide, I hope.
Yes.
Yeah. Okay. Thanks, Daniel. The status of QUIC in general, that was just covered by Daniel very nicely with the latest numbers. And I now give a short insight into what's the current status of HTTP3 in curl. We have now in the current development version, it fully integrated into the curl internal wirings, which means that it is functionally 99% on par with our HTTP2 implementation. So we support parallel transfers, we support resolve arguments to connection timeouts, all the usual features you have in the curl command line tool work also for HTTP3. So if you want to try this out, similar to HTTP2 connections, the first question is, of course, do you have a curl with HTTP3 support? So how can you check this? You run curl with a -V for this version, and you will see something like this, and in the version number for curl, and then a list of all the libraries that are included. And this is an example of curl built with the ng-TCP2 and ng-HTTP3 libraries, which bring QUIC support into curl. And in the features list, you will see HTTP3 if your curl supports this. Happy if you have this. If you do not, and consider building your own curl version, what are your options there? We support 3 backends in curl. Backends meaning the actual protocol implementation that curl uses. The first one, ng-TCP2 and ng-HTTP3. The status we give this is good. It passes all our tests. This is like the versions we use. And you see it's like 0.something versions. These libraries are still considered experimental by the makers. The second is Kish. It's a library from Cloudflare, also in a 0.something version. Passes also our tests, so it's on par with ng-TCP2. And the third one we have is MSH3. And there the status is still the experimental tag is justified there. There are some features or interoperation capabilities missing, and we are talking with the developers of that library how the situation can be improved. So this is more than for maybe testing the status, but not suitable for real use, I would say. All these backends are dependent on TLS libraries. As Daniel mentioned, the situation there is that the interface that QUIC needs for TLS is not standardized and is not provided by the major player OpenSSL so far. So there are differences, different libraries options available depending on the backend also. NGTCP2 is a pure C implementation. It's made by the author of the NGHTTP2 library, and this is the main backend that curl uses for some years now in its HTTP2 functionality. Dependencies is NGTCP2 can build with together with wolfSSL, with OpenSSL fork named the QUIC TLS fork, with GNU TLS, with Boring SSL, and with Pico TLS. It's a library from Fastly. So there are different options how to integrate this into curl with different TLS libraries. And the second one, Kish, is a pure Rust implementation. It's done by Cloudflare, available on their GitHub repository also. And it is built with Boring SSL together. And thirdly, the MSH3 is a C++ implementation done by Nick Banks from senior engineer at Microsoft. And it depends on the MS QUIC, that is Microsoft's own QUIC implementation. So if you have built or already have a curl that supports HTTP3, how do you use it? Well, you can just fire up a command and give as an option --HTTP3 and tell curl to use HTTP3 to connect to the site. Here's an example, connection to curl.se website, and we get a response, HTTP3, you see in the status line. So this is using HTTP3. You can connect to another site like Apache.org, and then you get a response HTTP2. Here, HTTP3 is not supported, and the fallback to HTTP2 is used. When you use another command line argument named HTTP3 only, then this fallback is not attempted and is just attempted to make a pure H3 connection. So this works with curl, but this fails with Apache, where you do not get a connection and the curl tool will report an error. So this is your way of, the first version is your way to safely retrieve your resource with possible use of H3 if the server responds to it, and a fallback otherwise, so you will always get the resource that you try to retrieve. And with HTTP3 only, you can really test that you only want to check this support and only use that version. So what's going on behind the scene a little bit, which is what we call HTTPS eyeballing. Curl will try two connections in parallel. One, like we see here, the connection to curl.se, where curl then, here's a little bit of trace output you can get from curl. It tries the UDP connect negotiations, then ongoing as usual. You get a success connected and using H3. This is the one when all things go well. In the second example, we have the fallback when we go to a site which does not support it. First, the UDP connection is attempted, then 100 milliseconds around that time pass without any valid answer. And then curl will fire up a second connection while the first one is still trying to connect. Of course, it might be that the server is slow or on the other side of a planet. But the second one is attempted using TCP. And in this case, this one succeeds. We get a TCP connection to apache.org and negotiate the HTTP2 protocol, and things are going. So this is what we call HTTPS eyeballing. You can say like, I want to try HTTP if it is available, and curl will take care of this, make parallel attempts, and whichever succeeds first, you will get them. So as a conclusion to the current state of H3 in curl, we have 2 backends fully wired in it. The backends we use are still 0.something versions, so they consider themselves experimental, and that is the main thing that is at this point in time holding us back from removing experimental tag of this protocol version in curl. Otherwise, when these backends, when these libraries say like we are stable now, we go into a 1.something version, we can go forward and also remove this from curl. Because of the experimental tagging, you will mostly get not a pre-built curl with H3 support, but we hope that will change in the near future. From usability, you can use it the same as it's now using with HTTP2. Curl will take care of giving you the resource you want to retrieve using the best protocol it finds support for. And you have other options to like the only version to play around with just the specific ones. Well, that was my part. Daniel, I think I would hand back to you now. Thanks.
Cool. I will do like this, and I will share my little thing here again. So I wanted to just briefly continue and show how to do HTTP3 then with libcurl. Really, since Stefan just showed you how to do it with curl, and I just wanted to get everyone to just quickly at least see how it's done with libcurl. I mean, it's really easy, and it's easy to find and learn too. So all of these features that were mentioned already, they're of course available if you do it with libcurl, of course, because libcurl is used by curl, so it's using all the things. So I just wanted to highlight how to do it with libcurl. Pretty much, if you want to do this, I want to have H3 but fall back to an older one if it doesn't work. You just ask for H3 in this HTTP version option. Yeah, if you ask for please give me HTTP3, that actually means try HTTP3, and if it and do this happy eyeball fallback thing that Stefan just mentioned. So and then of course you can do it with not mentioned previously, but you can do it alt service style. So you ask curl to support the alt service header, which is a way for a server to tell us that it supports another protocol on another server for a certain period of time into the future. And this is how you do it. You lose a round trip with this, so you have to actually ask first a server, and the server can tell the client, so hey, the next time you try me, you can talk H3 to this server over there, and curl supports that. And of course, mentioned previously how to check that you actually have HTTP3 support in libcurl. You can do it with this. I meant to show you just to highlight that there is this curl version info function that returns information about your libcurl, and it has a little bit called the version HTTP3 that you can check. If that's present, you have HTTP3 support. And again, this is still experimental, so most already pre-built binaries that you get will not have it enabled. So you pretty much need to build it yourself or rely on someone else to do it for you, a friendly person who does it. But of course, when back to the question, then I think Stefan touched it a little bit. When will we ship this for real? I mean, as in non-experimental. And I think I have this little ocean that because I think shipping is such a fun pun. But of course, we need to get, we had to get the specification in place. We had to get deployed service there and browser support. And then we need these QUIC and HTTP3 libraries, because we don't do all those binary bits ourselves, right, in the curl project. And then this TLS situation, the TLS library situation, ideally should get somewhere, right? And then we did libcurl, and it needs to do everything right. And then we can have curl use that and ship it everywhere, and everyone could run it everywhere, and we would be happy. But of course, and we got the specifications. We have a lot of deployed servers. All the big CDNs, all the big players are already shipping H3, as I showed you already. The browser support is there, but we're not quite there with the QUIC and HTTP3 libraries. They're all in beta versions, so they're all at. None of them have actually, the ones we are using, none of them have come to the sort of proper or real release state yet. We hope to them to go there, and I think that's the primary thing now that sort of makes us not say that our version of H3 support is non-experimental. The TLS situation is still in a bit of a hairy situation, primarily because OpenSSL does not support the APIs that we want, and they will not do that for another year or 3 or something. But you have to go with other solutions. Hopefully then, like, for example, just randomly said wolfSSL, for example, which supports QUIC since a while back now, solidly, and you can use that very good with curl. I could mention that when you pick a TLS solution with curl in general, curl will use that TLS library for all the protocols. So not only QUIC and QUIC, right, but for all the other HTTPS stuff. Sorry, not only, I mean, yes, HTTPS as well, and other versions, I mean, but also the other protocols that speak TLS. So it'll always just a single TLS library at any one point in time. So that's why it matters. We can't go with 2 different ones in runtime. And of course, in libcurl, the situation is now, I would say, pretty decent. So we're, as Stefan said, we are on par with how we do H2. So it's certainly good enough now to start playing with and experimenting even further and see how it behaves for you. But sure, it will take a while. Hopefully, ideally, at least one of these QUIC libraries will go out of their beta release versions this year. But I'm not sure exactly what to hope for, and I'm not the one to tell them what to do, or I'm not. So we're a little bit waiting for them to take that step. But as soon as they do that, I think we will be ready to remove the experimental tag from our side of things. And of course, if you're more interested in H3 details, I wrote this book a while ago that you can get. It's totally free. It's not that very big, but it presents details about HTTP3 if you want to get into some more details about it. And with this, I think I'm done with my little side of the presentation. So is there any questions, perhaps? I don't see anyone in the Q&A thing. Might, if there's anyone in Twitch who has a question, fire it away, and let's see if me and Stefan can answer it, maybe. Not a single question. So I could then just mention, since someone mentioned Rust. So there's out of the libraries that we support for H3 and QUIC, one of them is written in Rust, and the others are written in C. So there is a Rust alternative sort of in the works, and that's the Quiche library from Cloudflare. So that's certainly an option, possibly in the future. Well, then I guess we're done.
We have one question. Here, I'll read it out. Besides streams, how does QUIC compare with DTLS?
Oh, that's a good question. I think streams is one of the primary ones. I remember the question about using DTLS instead of QUIC was brought up during the work on QUIC, and it was dismissed pretty unanimously, but I don't remember exactly the details how it came to be. I think, for example, well, I think the streams are an important part, because the streams were one of the reasons, or rather the independent streams, the independency of the streams, that was one of the primary reasons for doing QUIC, right? Because that's one of the downsides with H2, since with H2 you could do a lot of streams over a single TCP connection, and when you did that and lost a packet, all of those streams over that same connection suffered. So having the streams independent for network loss situations was a sort of driving reason to do QUIC. And I don't think DTLS has anything like that, so you would have to do them differently. But I'm not an expert on DTLS at all, so I'm not really, I don't have a lot of good answers. Do you remember, Stefan?
I can't really. I think you said it quite well. I mean, basically from usability is there's no HTTP version defined over DTLS, right?
Right.
So the question is a little bit, if you just compare it on the internet protocol level without any HTTP semantics, I can't really say like what's the big advantage of QUIC over DTLS. I know what QUIC does, but I know too little about DTLS to answer.
Yes, me too. I would imagine, I without saying too much, I would imagine that the zero RTT and stuff like that, I mean, the low latency parts might also be a reason that it might be hard to get that low latency handshake and early data with DTLS plus HTTP2 or whatever it would do. It would still need a different HTTP, of course, even if it had DTLS.
Yeah. And even if you would map HTTP2 then as a byte stream on top of DTLS, you would have the same problem as with TCP with stream blocking.
Yes, yes.
So we have another question. What was the percentage increase in CPU for QUIC versus TCP again?
Enormous.
Yeah. Yes, it's like, how do you compare? I mean, if you take like a large download, many in parallel, full throttle, you see like 200 to 300% more CPUs used for a single connection than with the TCP H2 one. But that's not, it depends on the traffic, of course. I mean, then you're talking about like a fully loaded server and that it will just use more resources if you do full, if your emphasis is on the transfer. If it's smaller requests you're talking about, then the difference is not that large because it's less packets to encrypt and handle. More the request itself will take more time. So it depends on how much traffic you have in the server, what you actually will see. But you can, in peaks, you can expect 200 to 300%. But on slow requests, as I said, where the answering of the request takes more of your server resources, the difference will not be that large.
And also, one should also remember that people, or they don't generally deploy H3 for performance reasons like that. You don't increase transfer performance, you get lower latency, and that's what everyone wants with H3 and QUIC usually. Sort of, and the question is the price of the extra CPU worth the lower latency? And apparently in a lot of cases it is. So there's another question that says if it's if you're on a LAN with no packet loss, is the performance then the same as TCP, or is it slightly better? And again, I think the performance is fine. You can probably get the same performance as H2 to H3 if you have the CPU for it. So usually if you're CPU bound, you will get worse performance with H3, but if you're network bound, you should get close to the same performance in just raw network performance at least. But again, just comparing raw network performance is not really fair to H3, right? Because H3 you want it for the much lower latency, so you will get data faster, and you will get data more reliably especially, I mean, when on bad or slow networks, and that's why you want it. I guess in a data center or something, within the data center, you will not use H3. So, so the question then is if we can think of any reason to not to do QUIC over IPsec VPN across continents. I imagine that a lot of people will switch to QUIC for a lot of these situations. Absolutely. Because QUIC has a pretty fancy way to solve the problems with these TCP head of line things. So you don't have to implement your own things over UDP. You can do it with QUIC. So, and QUIC is an early days protocol still, right? So I think we're only seeing the beginning of QUIC. I think we're going to see a lot of more things being done, getting introduced to be done over QUIC instead of other protocols used in the past. So HTTP3 is just one of the first ones that is using this QUIC like this. There's going to be a lot of more protocols coming. So QUIC is going to be more and more used going forward. And especially for things like VPNs or tunneling data over other protocols. So there's also a lot of protocols, you know, tunneling QUIC over QUIC and stuff like that. And it's a protocol full of, like, it's meant to, and designed to get built further upon and to get enhanced over time. And I think we will see that going forward. As Stefan said, we don't have any questions right now, but when we compare networks performance speed with curl and doing H3 versus H2, is exactly like Stefan already explained, that if we do a lot of small transfers, they're pretty much on par speed-wise. But if you do many larger ones, especially local host, right, when we are CPU bound, we can see that H3 is slower because it takes much more CPU to do the transfers.
Yeah, exactly. But that's the current state 2023, right? This is not inherently going to stay that way if all optimize. I mean, people will continue to optimize. Operating systems will have a better UDP support because there's now more focus on it. So it will continue to develop. So what you see now is not the technical limitation per se. It's just the current way of things. It's like maybe you think about TCP 20 years ago. I mean, there were huge performance differences if you had a Microsoft machine talking to a Linux machine or not, and because things were not fully worked out yet. And I expect the same in QUIC to happen also.
Absolutely.
Okay, it seems like that was all the questions we had. So I think we can probably end it here. Thank you everyone for joining. Thank you, Stefan and Daniel, for the presentation. Do either of you have any closing words or statements before we end?
Nothing. Thanks for showing up and for the questions, and good to see you here. See you again in another thing going forward. And do try out the H3 support in curl. We do want people to try it out and tell us how it works and give us feedback so that we can really make sure that it is in a good state when the time comes and we want to remove that experimental label.
Yeah, everything Daniel said. Thanks a lot for coming here.
All right, awesome. Yep. Likewise, thank you everyone for joining. Enjoy the rest of the week.
Bye.
All right, goodbye.